Welcome to our comprehensive guide on the most frequently asked questions in Android interviews. Whether you're a beginner or an experienced developer, mastering these concepts can make a significant difference in your interview performance. We'll cover everything from Kotlin features to Android architecture, threading, UI, and system design. By understanding these topics, you'll not only be prepared for technical interviews, but also gain deeper insight into modern Android development practices. Let's dive in and explore the essential knowledge every Android developer should have for interview success. Extension functions in Kotlin allow you to add new functionality to existing classes without modifying their source code. This is especially useful when working with third-party libraries or standard classes. You can declare an extension function using the fun keyword, followed by the class name and function name. Extension functions enhance readability, promote separation of concerns, and improve code reusability. They also enable you to add methods to classes you don't own, making your codebase more modular and maintainable. This feature is particularly valuable when integrating Java code into Kotlin projects. Higher order functions are a core feature in Kotlin, allowing functions to accept other functions as parameters or return them as results. This enables more abstract and flexible code structures. For example, you can pass a function to another function to perform operations like filtering or mapping. Lambda expressions, which are anonymous functions, work seamlessly with higher-order functions, making code concise and expressive. These concepts promote functional programming, encapsulate behavior, and support modular code. By using higher-order functions and lambdas, you can create APIs that are both powerful and easy to use. Coroutines Flow and StateFlow are tools for managing asynchronous data streams in Kotlin. Flow is a cold stream, meaning it starts emitting values only when collected, and each collector gets its own stream. StateFlow, on the other hand, is hot and always active, holding a single updatable state. StateFlow is ideal for managing UI state in Android applications, as it instantly provides the latest value to new collectors. Both support structured concurrency and lifecycle awareness, but StateFlow is more suited for scenarios where you need to track and update a single state over time. Kotlin's null safety system helps developers avoid null pointer exceptions by explicitly defining whether variables can hold null values. Non-nullable types cannot be assigned null, while nullable types are declared with the safe call operator lets you access properties or methods safely, returning null if the object is null. The not-null assertion operator asserts that a value is not null, throwing an exception if it is. The Elvis operator provides a default value if the expression is null. These operators make handling nullability safer and more predictable. Inline classes in Kotlin wrap a single value and are optimized to avoid runtime overhead. Marked with a JVM inline, they prevent unnecessary boxing and reduce memory usage. Inline classes improve performance by allowing the compiler to use the underlying value directly without creating extra objects. They also enhance type safety, as you can create specific types for values that would otherwise be simple data types. This prevents accidental misuse and keeps your code clean and efficient. Inline classes are ideal for scenarios where performance and type safety are critical. The reified keyword in Kotlin is used with inline functions to retain type information at runtime. Normally, generic type information is erased, but reified allows you to inspect or operate on the type parameter within an inline function. This is useful for type checking, casting, and creating generic utility functions. By marking a generic function as inline and reified, you enable powerful runtime operations that are not possible with regular functions. This feature is especially valuable when working with generic APIs or libraries. Sync and await are coroutine builders in Kotlin that enable efficient handling of asynchronous operations. The async builder launches a coroutine asynchronously and returns a deferred object, representing a future result. The await function is called on a deferred to retrieve the result once it's ready, suspending the coroutine without blocking the thread. This allows tasks to run concurrently, improving performance and keeping the UI responsive. Sync and await are essential for scenarios like network requests or parallel computations in Android apps. ViewModel and LiveData are core components of Android's architecture, designed to manage UI-related data in a lifecycle-aware way. ViewModel stores and manages data for UI controllers, persisting it across configuration changes like screen rotations. LiveData is an observable data holder that notifies UI components when data changes, ensuring automatic updates. Together, they separate UI logic from business logic, handle configuration changes, and promote a reactive UI. This combination leads to cleaner, more testable, and robust Android applications. Room is an Android Jetpack library that provides an abstraction layer over SQLite, simplifying database management. Unlike SQLite, which requires manual SQL queries and connection handling, Room uses annotations and generates SQL code automatically. Room offers compile-time verification of queries, integration with live data and flow for lifecycle-aware data observation, and structured migration support. The DAO pattern in Room streamlines data access, making code more readable and maintainable. Room is ideal for efficient, safe, and modern database operations in Android apps. Dispatchers in Kotlin coroutines determine the thread or thread pool on which a coroutine runs. Dispatchers. Main is used for UI updates on the main thread, dispatchers. I/O handles blocking I/O tasks like file and network operations, dispatchers. Default is optimized for CPU-intensive tasks, and dispatchers. Unconfined starts coroutines in the caller's context. Choosing the right dispatcher ensures efficient concurrency and parallelism, keeping your app responsive and resource efficient. Understanding dispatchers is crucial for managing coroutine execution contexts in Android development. Live data is a lifecycle-aware observable data holder that notifies UI components of data changes. Mutable live data extends live data, allowing you to modify the stored data using setValue or postValue. Live data prevents memory leaks by updating only active observers, while mutable live data enables dynamic data updates. Together, they simplify UI data management, ensuring that changes are reflected automatically and safely. These components are essential for building responsive and robust Android UIs. Launch modes in Android determine how activities behave when started. Standard mode creates a new instance each time. Single top reuses the instance if it's on top. Single task ensures only one instance exists in the task, and single instance runs the activity in its own task. Understanding launch modes helps manage activity instances, navigation, and user experience. Choosing the right mode is crucial for scenarios like notifications, main screens, or standalone settings pages. Jetpack Compose is a modern toolkit for building native Android UIs using a declarative programming model. Composables are the building blocks, and state management ensures automatic UI updates. Recomposition updates the UI when state changes, making it efficient and responsive. Scaffold provides a basic structure for material design layouts, including top app bars, bottom navigation, and floating action buttons. Compose simplifies UI development, reduces boilerplate, and enables beautiful, dynamic interfaces. Improving Android app performance involves optimizing UI rendering, managing memory efficiently, and reducing background process overhead. Use RecyclerView for lists, apply the viewholder pattern, and minimize overdraw. Avoid memory leaks with lifecycle-aware components and optimize bitmap usage. Efficient background processing with Work Manager and asynchronous operations keeps the UI responsive. Network efficiency, app size reduction, and database optimization are also key. Monitor performance using Android Profiler and benchmarking tools, and implement caching strategies for frequently accessed data. Coroutines simplify asynchronous programming in Kotlin by allowing non-blocking code that's easy to read and maintain. They're lightweight, enabling thousands of coroutines with minimal overhead, unlike traditional threads which are resource-intensive. Coroutines follow structured concurrency, are easy to cancel, and are scoped to lifecycle contexts, preventing memory leaks. Traditional threading can lead to complex code, UI freezes, and resource leaks. Coroutines make Android apps more responsive and manageable. In Kotlin, var declares mutable variables, allowing their values to change after initialization. Val declares read-only variables, which cannot be changed once set. Const is used for compile-time constants, which are always immutable and can only be applied to top-level or object properties. Understanding these keywords helps manage mutability and ensure safer, more predictable code. Use var for variables that change, val for immutable values, and const for constants needed at compile time. Data classes in Kotlin are designed to hold and manage data efficiently. They automatically generate useful methods like equals, hashcode, toString, and copy, reducing boilerplate code. Data classes enhance readability, support immutable data with val properties, and make debugging easier. The copy method allows for easy creation of modified instances, promoting functional programming. Use data classes when you need concise, clear, and robust data holders in your application. Sealed classes restrict class hierarchies to a specific set of types, making them ideal for representing restricted states or outcomes. Subclasses can only be defined within the same file, enabling exhaustive when statements and improving safety. Sealed classes are useful for modeling situations with limited possible states, such as network results or event handling. They ensure all cases are handled at compile time, reducing errors and enhancing code clarity. Inline keyword in Kotlin optimizes higher-order functions by reducing function call overhead. When a function is marked as inline, the compiler substitutes its code directly into the caller, eliminating stack creation. Inline functions are especially useful with Lambda expressions, saving memory and improving performance. They also enable reified type parameters, allowing access to actual type information at runtime. Use inline for small, frequently called functions or when passing lambdas. Suspend functions are a cornerstone of Kotlin coroutines, enabling asynchronous, non-blocking code in a sequential style. Marked with the suspend keyword, they can be paused and resumed, allowing long-running operations like network calls without blocking the main thread. Suspend functions must be called from a coroutine or another suspend function. This approach keeps the UI responsive and simplifies complex asynchronous workflows. Scope functions in Kotlin make code concise and readable by executing a block within the context of an object. The main types are apply, let, run, with, and also. Apply and also return the object itself, while let, run, and with return the result of the lambda. Scope functions temporarily bring an object into scope, making configuration, operations, and chaining easier. They're essential for clean, idiomatic Kotlin code. Latnet and lazy are used for property initialization in Kotlin. Latnet is for mutable properties var that are initialized later, commonly used for dependency injection or lifecycle methods. Lazy is for properties initialized only when first accessed, typically used with val for expensive computations. Latnet requires manual initialization, while lazy handles initialization automatically. Choosing between them depends on when and how you need the property initialized. Android manages memory using garbage collection, memory allocation based on component lifecycle, and low memory management. To avoid memory leaks, use weak references, avoid long-lived context references, and leverage lifecycle-aware components like viewModel and livedata. Clean up resources in lifecycle methods and use tools like Android Profiler or Leak Canary for analysis. Proper memory management ensures app stability and performance. Dependency injection (DI) is a design pattern that provides an object with its dependencies from external sources, promoting loose coupling and testability. DI can be implemented via constructor, setter, or interface injection. It improves code reusability, maintenance, and separation of concerns. Popular DI frameworks in Android include Dagger, Hilt, and Coin. DI is essential for scalable, maintainable, and testable Android applications. Parcelable is an efficient way to serialize objects in Android, designed for passing data between activities or fragments. It avoids reflection, making it faster and more memory efficient than serializable, which is a Java standard interface. Use parcelable for Android-specific tasks and serializable for simpler, non-performance-critical scenarios. Understanding the difference ensures optimal data transfer and resource usage in your app. Work Manager schedules deferrable, guaranteed tasks, suitable for background data sync or uploads. Job Scheduler manages long-running background jobs under system constraints like battery or network. Alarm Manager schedules tasks at specific times but doesn't guarantee execution if the device sleeps. Choosing the right manager depends on task requirements, execution guarantees, and system optimizations. These tools are vital for robust background processing in Android. Android 8 Oreo and above restrict background execution to save battery and improve performance. Foreground services are required for ongoing background processing. Job Scheduler and Work Manager are recommended for deferred or periodic tasks, adhering to system optimizations. Broadcast receivers have limitations and should be used carefully. Understanding these changes is crucial for building efficient, compliant Android apps. Livedata is lifecycle aware, updating only active observers and ideal for UI updates. StateFlow is a Kotlin flow designed for state handling, supporting cold streams and structured concurrency, but requiring manual lifecycle management. Use livedata for UI-bound data and StateFlow for business logic or shared state management. Choosing the right tool ensures efficient, responsive, and maintainable Android applications. Optimizing recycler view involves using the viewHolder pattern, implementing getItemViewType for multiple view types, and leveraging diffutil for efficient updates. Minimize complex views, use constraint layout, and implement paging with paging 3 for large datasets. Prefetch views and use recycle view pool for reuse across recycler views. These strategies ensure smooth scrolling, efficient memory usage, and responsive UI in Android apps. Kotlin generics allow you to write flexible and reusable code by parameterizing types. Generics are used in collections, functions, and classes to operate on different data types without sacrificing type safety. Understanding generics is essential for building robust APIs and handling complex data structures in Android development. They enable code reuse and reduce duplication, making your codebase cleaner and more maintainable. System design interviews test your ability to architect scalable and efficient systems. Focus on modularity, scalability, and maintainability. Understand how to break down requirements, choose appropriate technologies, and design for performance and reliability. Practice explaining your design choices, handling trade-offs, and considering edge cases. Strong system design skills are essential for senior Android roles and technical leadership. VVM, Model View Model, is a popular architecture pattern in Android development. It separates UI logic view from business logic view model and data model, promoting testability and maintainability. View model manages UI-related data, live data observes changes, and the model handles data operations. MVVM leads to cleaner, more modular code and simplifies lifecycle management, making it ideal for modern Android apps. Kotlin multi-platform enables code sharing across Android, iOS, and other platforms. By writing common business logic in Kotlin, you reduce development time and maintain consistency. Multi-platform projects use expect actual declarations to handle platform-specific implementations. This approach streamlines development, reduces duplication, and accelerates feature delivery. It's especially valuable for teams targeting multiple platforms. Jetpack Compose supports rich animations, transforming static interfaces into dynamic, engaging experiences. Animations can be applied to UI elements for transitions, state changes, and user feedback. Compose provides APIs for simple and complex animations, making it easy to create visually appealing apps. Well-designed animations enhance user experience and make your app stand out in a competitive market. The state design pattern is used to manage state transitions in Kotlin and Android apps. It encapsulates state-specific behavior and transitions, making code easier to maintain and extend. By using sealed classes or enums, you can represent different states and handle them exhaustively. This pattern is valuable for managing UI states, network responses, and complex workflows, ensuring predictable and robust behavior. Effective testing strategies are crucial for reliable Android apps. Use unit tests for business logic, UI tests for user interactions, and integration tests for end-to-end scenarios. Leverage frameworks like JUnit, Espresso, and Mockito. Modern testing approaches include mocking dependencies, testing view models, and using dependency injection for testability. Regular testing ensures app stability, reduces bugs, and accelerates development. Junior Android developers often make mistakes like improper memory management, inefficient UI rendering, and neglecting lifecycle awareness. Avoid static references to context, use recycler view for lists, and leverage view model and live data for data handling. Regularly profile your app, optimize network calls, and follow best practices for architecture and testing. Learning from common mistakes accelerates growth and improves code quality. Android 16, codenamed Baklava, introduces new features for users and developers, enhancing usability, performance, and security. Stay updated with the latest platform changes, APIs, and best practices. Understanding new features helps you leverage platform capabilities and deliver innovative, high-quality apps. Regularly review Android release notes and experiment with new tools and libraries. Generics in Java provide type safety and flexibility, allowing classes and methods to operate on different data types. They're widely used in collections, APIs, and frameworks. Understanding generics is essential for Android development, as many libraries and platform components rely on them. Proper use of generics reduces runtime errors and improves code clarity, making your applications more robust. Data science and AI are increasingly relevant in Android development, powering features like recommendation systems, image recognition, and natural language processing. Integrate machine learning models using TensorFlow Lite or MLKit, and leverage data science techniques for analytics and personalization. Understanding AI concepts expands your skill set and opens new opportunities in mobile innovation. Natural language processing, NLP, enables Android apps to understand and process human language. Use NLP for chatbots, voice assistants, and text analysis. Integrate libraries like MLKit or TensorFlow Lite for language detection, sentiment analysis, and translation. NLP enhances user experience and enables innovative features, making your app more interactive and intelligent. Explore staff picks and recommended resources for Android development, including blogs, tutorials, and community stories. Staying informed about industry trends, best practices, and expert advice accelerates learning and keeps you ahead in your career. Engage with the developer community, share knowledge, and continuously improve your skills for long-term success. We've covered the top questions and concepts for Android interviews, including Kotlin features, architecture patterns, threading, UI optimization, and system design. Mastering these topics prepares you for technical interviews and strengthens your development skills. Keep practicing, stay updated with platform changes, and apply best practices in your projects. With dedication and continuous learning, you'll excel in Android development and interviews. Thank you for joining this deep dive into Android interview questions and concepts. Continue exploring, practicing, and building projects to reinforce your knowledge. Connect with the Android developer community, seek feedback, and stay curious. Your journey in Android development is ongoing, and mastering these fundamentals will open doors to exciting opportunities. Good luck with your interviews and future projects.